Let's make a cake. When making a cake, you're going to need a set of ingredients to make it possible. You're going to need some eggs, a cup of milk or water, depending on what kind of cake mix you're using, and a little bit of vegetable oil. You're going to mix all that stuff together and then pour it into a cake pan and put it in the oven. You're going to put it in the oven for a certain amount of heat and a certain amount of time to get your product. A sweet tasting cake. Why do we need to have balanced chemical equations, you may ask? The reason why chemical equations have to be balanced is all because of the law of conservation of matter. What this law states is that in a closed system, matter cannot be made or destroyed. Sure, matter can change physically, like how our cake went from liquid to solid. However, deep down inside, it is still the same thing. In a chemical equation, the mass of the chemicals never change. However, the atoms are rearranged. No matter what chemicals you're mixing, the total mass of the product will always match the reactants. Let's do two unbalanced equations together so that you can get a better idea. Example 1. When writing chemical equations, the left side will always be known as the reactant, while the right side will be known as the product. We call it this because the reactants together make the product. First, we're going to count how many atoms we have on each side of the chemical equation. Note that the only thing that could be changed is the coefficients, which will appear in front of the atoms. The subscripts that could be found at the bottom of the atoms cannot be changed. In this case, we have copper and 8 sulfurs to give us copper sulfide. On the reactant side, we originally only have 1 copper. On the product side, we have 2 coppers. This needs to change. First, we're going to work with the sulfur. If we have 8 sulfurs on the reactants, we're going to need 8 sulfurs on the products. Luckily, we have only 1 sulfur on the product, so 1 times 8 is going to give us 8. Now both the sulfurs are balanced. Let's go back to the copper. We only have 1 copper on the reactant and 2 coppers on the product. We could multiply that 8 that we got from the sulfur on the reactant side and do 2 times 8 to give us 16 because there are 2 coppers. Now this is perfect, so we could go to the reactant side of the copper and do 1 times 16, which will give us 16. This equation is now balanced.